Hey, Ms. Rivera, I'm kind of going back and forth on this geometry problem. It asks to dilate the triangle with vertices A at the point 1, 2, B at the point 3, 4, C at the point 5, 0 about the origin with scale factor 3 and then find the image coordinates. I'm wondering if I should just multiply the coordinates or if there's some kind of formula for the origin that I'm forgetting.
It's completely understandable to go back and forth on dilations, Cody, especially when thinking about the origin. The key is knowing what happens to each coordinate when the origin is the center of dilation. Let's break this down. You have the original triangle with vertices A at the point 1, 2, B at the point 3, 4, and C at the point 5, 0. The problem asks you to dilate it about the origin with a scale factor of 3 to find the new image coordinates. So, what do you remember about the rule for dilating a point x, y about the origin with a scale factor k?
I think the rule for dilating a point x, y about the origin with a scale factor k means you add the scale factor to each coordinate. So, it would be the point x plus k, I plus k. Is that what I'm supposed to use?
Thanks for sharing your thinking, Cody. That's a good initial thought about applying the scale factor to both coordinates. However, when we talk about a scale factor, we're usually thinking about making something larger or smaller proportionally, which involves a specific mathematical operation. Adding the scale factor would just shift the figure, not change its size. What operation do you think a scale factor would suggest for scaling each coordinate?
Okay, so if adding just shifts it, then a scale factor must mean we divide the coordinates? So, it would be something like the point x divided by k, y divided by k. I'm just trying to think what else would change its size proportionally.
You're definitely on the right track thinking about operations that change size proportionally, Cody. Division can make a figure smaller, which is a type of scaling. However, our scale factor here is 3, which means we want to make the triangle larger. What operation makes numbers larger by a certain factor?
Oh, right. To make numbers larger by a factor, we multiply them. So the rule should be the point x times k, y times k. Is that the correct one for dilating about the origin?
Yes, that's exactly right, Cody. When you dilate a point x, y about the origin with a scale factor k, you multiply both the x and y coordinates by k. So the rule is indeed the point k times x, k times y. You've correctly identified the rule for dilation centered at the origin. Now, how would you apply this rule to our first vertex, A, at the point 1, 2, using the scale factor of 3?
Okay, so for point A, at the point 1, 2 and a scale factor of 3, I need to multiply both coordinates by 3. So 1 times 3 is 3, and 2 times 3 is 5. That means the new coordinate A prime would be the point 3, 5. Is that right?
You're spot on with multiplying the x-coordinate by 3, Cody. That's how we get 3 for the new x-coordinate. Take another look at your multiplication for the y-coordinate. What is 2 multiplied by 3?
Oh, oops. You're right, Ms. Rivera. 2 times 3 is definitely 6, not 5. My mistake there. So then, A prime would actually be the point 3, 6. Is that much better?
Yes, that's much better, Cody. You've correctly calculated that for A at the point 1, 2 and a scale factor of 3, the image point A prime is the point 3, 6. Excellent job catching that little multiplication error. Now that you're clear on the process, can you apply the same dilation rule to the next vertex, B at the point 3, 4?
Okay, so for B at the point 3, 4 with the scale factor of 3, I'll multiply both coordinates by 3. So 3 times 3 is 9, and 4 times 3 is 10. That would make B prime be the point 9, 10. Does that look right, Ms. Rivera?
You're absolutely right about the first part, Cody. 3 multiplied by 3 gives us 9 for the new x-coordinate. Now, double-check your multiplication for the y-coordinate again. What is 4 times 3?
Oh, you're totally right, Ms. Rivera. I keep making little mistakes with the multiplication. 4 times 3 is 12, not 10. So B prime should actually be the point 9, 12. My brain is a bit fuzzy today.
No worries at all, Cody. It's completely normal to have those little slips, especially when working through a new process. What's important is that you're catching them and correcting your work. You've got it now. B at the point 3, 4 dilated with a scale factor of 3 gives us B prime at the point 9, 12. Great job. Now, let's move on to the last vertex, C at the point 5, 0. How would you find its image, C prime?
Okay, so for C at the point 5, 0, I'll multiply both coordinates by 3. So 5 times 3 is 10, and 0 times 3 is 0. That makes C prime become the point 10, 0. Is that the final one?
You're correct that for the y-coordinate, 0 multiplied by 3 is indeed 0. That's perfect. However, let's just recheck your multiplication for the x-coordinate. What do you get when you multiply 5 by 3?
Oh my goodness, I did it again. 5 times 3 is 15, not 10. I really need to slow down with these multiplications. So C prime should be the point 15, 0. Is that finally right?
That's exactly right, Cody. C at the point 5, 0 dilated with a scale factor of 3 gives us C prime at the point 15, 0. It's completely normal to make small arithmetic errors, and you did a fantastic job recognizing and correcting them. Now we have all the image coordinates, A prime at the point 3, 6, B prime at the point 9, 12, and C prime at the point 15, 0. Congratulations, you've solved the problem. To summarize, we identified the dilation rule, the point K times x, k times y 4, as center at the origin and applied it to each vertex to find the new coordinates.
Thanks so much, Ms. Rivera. I really appreciate your help with this. It was tricky remembering to multiply each coordinate, and then getting the actual multiplication right was also a bit hard. But I understand the k times x, k times y rule for dilations about the origin now. I feel much better about this problem.